Hi, my name is Joshua, and today we're going to look at one of the problems that the students posted on Facebook. And for this problem, we're going to try to find the first three non-zero terms of its Taylor series centered at zero. Now, first looking at this problem, you may want to use the easier method, an easy method, which is to set EX equal to its Taylor series expansion at zero, which is x to the power of n over n factorial, and cosine x to its Taylor series expansion, which is, oh, pardon me, this goes from 1 to infinity. And here this goes from, oh crap, this goes from 0 to infinity, I believe. Yes, 0 to infinity. And it's negative 1k x 2k over 2k factorial. Okay, so you may want to set this up this way and then try to multiply them. But you have to keep in mind that these are infinite sums. And to do that, you would have to multiply every single number in the partial sums by for e to the x times every single polynomial here also. So that way it's just not practical. So what we can do is we actually just have to do it the regular way, which is by taking the derivatives and then using this formula for the coefficient. And then finding a power series Taylor series representation that way. So let's go ahead and take the derivatives. F of x is just a function, and we're going to be using this little subscript up here to represent the derivative that we're at. So here we have e to the x cosine of x. In the second place, we have f1 of x, which would represent the first derivative. And here, just by the simple product rule, we have cosine x plus e to the x negative sine of x. And now if we plug in 0 into this function, it'll give us here 1. And here we have 0. So this is equal to 1. And remember, the reason why we're plugging this in is because we are going to take basically this right here, this expression right here, is what we're going to use to find the coefficient. And the coefficient, just to remind you, fits in this way. This is how we define power series from 0 or 1. And we do x minus a. A is the point you center that to the power of n. So once again, we're going to replace Cn, the coefficient, with this expression. Okay? So now we take the second derivative. What do we get? For that, we get e to the x cosine x plus e to the x negative sine x. And you can go through and check all these derivatives later just to make sure that they're correct. E to the x negative sine of x plus e to the x, negative cosine x. And now if we plug in 0, what do we get? We should end up with 0 for the second term, for the second coefficient there. And now if you go ahead and third derivative at x, what we should end up getting is something like e to the x cosine of x plus e to the x negative sine of x plus 2 times e to the x negative sine of x. Bear with me, this is a little complicated. Plus e to the x negative cosine of x plus e to the x negative cosine of x plus e to the x sine of x. And just be careful that you're taking these derivatives right, because it's easy to mess up, obviously, given that the derivative of cosine is negative sine and the derivative of sine is cosine. One more hint, notice that you do not have to keep taking the derivatives over and over again. The terms are actually repetitive. So here we see that we take the derivative of e to the x cosine of x, and that gives us this expression right here, right? And so when we're taking the second derivative, we don't have to reevaluate that. We simply have to copy this down, e to the x cosine x plus e to the x negative sine of x, and place that right here. And then we will take the derivative of e to the x negative sine of x using the product rule, and that gives us that expression right there. And you can repeat that same method to get the third derivative. So here we should get that at 0, this should equal -2, right? And once again, you can check this by plugging in 0 into for x here and finding the actual value. Now what we're gonna do is we're gonna take these expressions, right? These values that we've gotten, and we're gonna plug them here, because essentially we're taking the derivative, we're finding an expression for the derivative of the function and then plugging in the point we want. So if you end up doing that, if you do that, you end up getting that the Taylor series for this function, let me not write that, we actually do it this way because it's truncated. Truncated Taylor series for this function is actually equal to 1 x minus a to the power of 0 over 0 factorial plus plus 1 over 1 factorial. 1 over 1 factorial x minus a to the power of 1 plus 0 x minus a to the power of 2 over 2 factorial plus -2 x to the power of a to the power of 3 over 3 factorial. And let me flip the page here. What that should give us is 1 plus x minus 0 plus 2x cubed over 3 factorial. And these are the first 3 non-zero terms in the Taylor series.